on heat flow, and the cup of hot water is placed into the cup that's filled with cold water. So the heat flows from the hot water into the cold water and the cup, and the thermal equilibrium is reached, as well as in the thermometer probe, it reaches equilibrium too.
To calculate the heat flow into each object, we set the heat flow from the hot water equal to the heat flow of the cold water plus the heat flow into the cup. We used the MC equals delta T formula, plugging in the mass, specific heat, and the final temperature minus the temperature of the cold water for the cold objects, and for the hot object, the delta T was equal to T of the hot object minus the final temperature to keep them positive. As we plugged in the numbers, we were able to calculate for the final temperature, which we solved for TF and got a solution of 39.86 degrees Celsius, which is the equilibrium temperature reached by all objects.
Using the final temperature calculated, we can plug it into the heat flow equation and use that for the delta T to find the change in temperature. From this, we can tell that 2,574 calories of heat was lost from the hot water, and 2,008.9 calories were transferred and gained to the cold water, and 103.34 calories were given to the cup.
This graph shows the temperature of the cold water and how the temperature increases until it reaches thermal equilibrium and levels off at 37.5 degrees for the final temperature. And when we calculated the final temperature with our equation, we got 39.86, so that's a 5.9% error.